Hello students, this is Unit 7, Covalent Bond. Have you ever imagined riding an elevator all the way up to space? This idea may sound like a science fiction, but it may be possible thanks to carbon nanotube technology. A carbon nanotube technology is a microscope tube made by rolling a 1 carbon thick sheet of carbon atoms. Carbon nanotubes are extremely strong, durable, and lightweight. Due to these unique properties, it has been suggested that carbon nanotubes can be used to build the space elevators. How are these carbon atoms in the carbon nanotube joined together? How does the bonding between the carbon atoms account for the properties of carbon nanotubes? Let's explore it in this unit. Basically, carbon nanotubes are containing carbon atom in them, and that carbon atoms are connected with one another with the help of a linkage which is called as covalent bond. What is covalent bond? Covalent bond is a bond which is produced between two atoms by sharing of electrons. Atoms share their electrons in order to get stability or either attain the noble gas configuration. There are two types of electrons which will be present on an atom: bonding pair or lone pair of electrons. The bonding pair electrons are those electrons which are involved in the bond making or which are shared between atoms, whereas the lone pair electrons are those electrons which are not involved in bond making. Electrons can be shared in the similar elements and they can also be shared in the different elements in order to produce covalent compounds. So when the electrons will be shared in the similar elements, so as a result we will be getting diatomic molecules such as hydrogen, oxygen, chlorine, nitrogen, and so on. There are so many elements which are present in a diatomic state in nature, and all of them are produced due to covalent bonding and sharing of electrons. Here is checkpoint 1, which is chlorine. So formation of chlorine molecule is dependent on sharing of electron. A chlorine atom has 7 outermost electrons. We all know that because there are 7 electrons in the outermost orbit of chlorine. Chlorine has electronic configuration 287 as its proton number is 17. So this is its electronic configuration. So if I will just draw the valence shell of a chlorine, so this would be the dot and cross structure of chlorine. 2, 3, 4, 5, 6, 7. There are 7 electrons in the valence shell, and similarly the second chlorine also has 7 electrons in the outermost shell or in the valence shell. As both of these chlorine are having 7 electrons in the valence shell, so they need one electron in order to fulfill their octet, or either they want to attain the noble configuration of a noble gas. So they will approach each other and they will share this pair of electron, and as a result we will get chlorine, a diatomic molecule of chlorine. This is called as dot and cross structure of chlorine. In dot and cross structure, the electrons of one atom will be represented as dots, whereas the electrons of the second reacting atom will be represented as cross. So that's why we used to call it as dot and cross structure. Checkpoint 2 is oxygen. Oxygen is always found as a diatomic molecule in nature, and its atomic number or proton number is 8. So its electronic configuration will be 2 and 6. There are 6 electrons in oxygen and it needs 2 more electrons in order to fulfill its octet or either noble gas configuration. So let's draw its valence shell. This is oxygen and this is its valence shell. These are the electrons which are present in the valence shell. So it will react with another oxygen atom and share 2 pairs of electrons. There is a sharing of 2 pairs of electrons between 2 atoms. So as a result we will get a diatomic molecule of oxygen. Next is nitrogen. Nitrogen is also a diatomic molecule and its atomic number is 7, so its electronic configuration is 2, 5. Therefore there are 5 valence electrons in the valence shell of nitrogen. If I will draw its dot and cross structure, so this nitrogen has 5 electrons, and the other nitrogen will also be having 5 electrons. So how are they going to react with one another? Let's have a look at it. Nitrogen, 1, 2, 3, 4, 5. And this one is having 1, 2, 3, 4, 5. So what will happen? These 3 pairs of electrons will be shared between 2 atoms, and as a result we will be getting 3 covalent bonds in between 2 nitrogen atoms. Or you can write this as diatomic molecule of nitrogen. Now, covalent compounds can also be produced by sharing of electrons between dissimilar atoms. So a very common example of this is water. In case of water, we know that water is produced by the reaction of 2 hydrogens with 1 oxygen. What will happen? This is the valence shell of oxygen, whereas this is the valence shell of 1 hydrogen, and this one is the second one. As a result, what will happen? Which structure will be produced? As a result, we will be getting a molecule like this. This is hydrogen, this is oxygen, this is hydrogen, and in this place where overlapping took place, we are going to share the bond pairs of electrons. So this is how we are going to get the structure of water molecule. If I will write its molecular structure, so it will be, the open molecular structure will be like this. 1 oxygen connected with 2 hydrogens, or its molecular formula is H2O, or we can also say HOH. Next checkpoint is methane. In case of methane, 1 carbon atom is connected with 4 hydrogens. This is its molecular formula. The outermost orbit of carbon is having 4 electrons. So it needs 4 more electrons in order to fulfill its octet. What it will do? It will react with 4 hydrogens, and each of the hydrogens are having 1 electron in their valence shell. So this is how the shared pairs of electrons will be represented. So this is the structure of methane. CH4 open structure, and this is its dot and cross structure. Next checkpoint is about carbon dioxide. In case of carbon dioxide, carbon is connected with 2 oxygens. Di means 2, oxide means oxygen. So there are 2 oxygens connected with carbon, and this molecule having sharing of electrons and covalent bonding. So this is how it's going to be represented. We are having carbon connected with 2 oxygens. Carbon has 4 electrons in the outermost orbit, whereas oxygen has 6 electrons in the outermost orbit. These are the shared pair of electrons, and these are the non-shared pair electrons of oxygen. So this is how the molecule of carbon dioxide will be formed, and carbon will be having double bond with both of these oxygens, and as a result we will be getting carbon dioxide. How covalent compounds can be classified? Covalent compounds can be classified on the basis of either their bonds or polarity. On the basis of bond, the covalent compounds either contain a single bond, a double bond, or a triple bond. Let's take example of them. Hydrogen is the best example to explain the single covalent bond. In case of hydrogen, there is 1 electron pair shared in between 2 hydrogen atoms, so that's why there would be a single covalent bond. If we look at double covalent bond, so oxygen is its example. In oxygen, 2 electrons are shared from each of the atom, and there are two electron pairs shared between two atoms. So this is how we are going to get this dimolecular structure. Next is triple covalent bond. Nitrogen is the best example to explain triple covalent bond. Whenever there are sharing of three pairs of electrons between two reacting atoms, so that is called as triple covalent bond. Polarity. What is polarity? Polarity is basically formation of charges. Whenever there are charges on any compound, positive and negative both, so it means that compound is polar. So on the basis of polarity, the compounds can either be polar covalent compounds or they can either be non-polar covalent compounds. The polar covalent compounds are those covalent compounds which are having two dissimilar atoms connected together. Let's suppose we are taking the example of hydrogen chloride. Here hydrogen and chlorine are dissimilar, and there is an electronegativity difference in between both of them. Electronegativity is basically the tendency of an atom to attract the shared pair of electron towards itself. So here in case of this, there is an electronegativity difference between both of them, and due to which this hydrogen will be having a partial positive charge, whereas this chlorine will be having a partial negative charge, and they both attract each other, and as a result we will get hydrogen chloride or hydrochloric acid. If we talk about non-polar covalent compounds, so the non-polar covalent compounds are always present in between all those compounds which are similar plus all those elements which are present in the compound which are having zero electronegativity or their electronegativity power is same. If we will take the example of hydrogen, diatomic molecule of hydrogen is produced due to two hydrogens and there is no electronegativity difference, both of them are same, so that's why it's a non-polar covalent compound. How can we write the formula of covalent compounds? To write the chemical formula of a diatomic molecule, we simply add a subscript 2 after the chemical symbol of the formula. Let's suppose bromine, this is its symbol Br. So after writing the symbol, we have to just put subscript 2 over here. In case of triatomic molecule, again, just we need to put a subscript after writing the symbol, such as ozone. This is the chemical formula of ozone, which is also a covalent compound. We just put 3, which is the subscript at the end. But some molecules of element are made up of a large number of atoms. For simplicity, their chemical formula are often represented by the chemical symbol of the element. Let's suppose if we take the example of sulfur, which contains 8 atoms, is represented by S. Though it contains 8 atoms, but still it will be represented as S in order to simplify it. Very often we can derive the chemical formula of a covalent compound from its chemical name. The chemical name of a covalent compound usually indicates the elements which are present inside the molecule, may contain a prefix, and the prefix will also tell us the number of atoms of the element. Let's take an example in order to understand it. Let's suppose we are having sulfur dioxide. So here you can see that this S is depicting the element, the name of the element, whereas this prefix sulfur dioxide, di is depicting this element. So it is indicating that there are 2 oxygens are there. So that's why we are saying sulfur dioxide. So this is the checkpoint, dinitrogen monoxide. In order to write down its chemical formula, here you can see this di is used as a prefix in order to represent the number of nitrogens in the compound, whereas this monoxide is used as a prefix to indicate the number of oxygen in the compound. So the formula will be N2O. Why it will be N2O? Because dinitrogen monoxide means this 2 will be used as a subscript in order to indicate the number of nitrogens, and monoxide means 1 oxygen will be there. So this is it for this lecture. The remaining part of the unit will be explained in the coming video. Thank you so very much.